So here we have this theorem. Let f be a function from a to b. By the way, a is we call it the domain of the function f. B is the codomain of the function f. And we can write it like this. A, b function. A is the domain of function f. B is the codomain of f. And you can also write for x. We know that f is a subset of a cross b, right? And it's the set of ordered pairs x, y, right? Satisfies existence and uniqueness condition. Anyway, y is the value of f of x, and we can write as y equal to f of x. And therefore we can just think f as the set of ordered pairs x, f of x for x in A. So now we have a function f from A to B, a function g from A to B. F and g are equal. We need to prove this theorem. F and g are equal. Two functions are equal. If and only if for all x in A, f of x equal to g of x. Okay, this is an if and only if statements. We need to show this theorem, so we need to do it in both directions, right? And f and g are equal. Now, what does that mean? F and g are equal. Two functions are equal. So function as we define in terms of set. So actually this means two sets are equal, right? Okay, now let's prove the first part. F and g are equal. So suppose f and g are equal. And we need to prove that need to show for all x, f of x equal to g of x. Okay, how to prove that? That's what we do. Let x be an element in A. We want to show f of x equal to g of x. So let x in A, we have, since x in A, we have x, comma, f of x. By definition, that's what we just talked before. This is in F, right? Function. So it's just, we have x in A, we have ordered pair x, comma, f of x. Recall that this is a value of f at x, and this is unique for x. So f of x is in F. But now by our assumption or our hypothesis here, f and g are equal. Say f and g are equal. Since f equal to g, we have f of x is an element of g. So why is this? F equal to g. I can just replace f equal to g, right? Replace f by g. So f of x is belong to g. So this, what does that mean? G is a function, the set of ordered pairs, right? X, g of x for x in A. Right? So both the domain of function f and g is A. So we have x, f of x is in g. So just recall here that g is the set of x, comma, g of x. X in A satisfies some condition, right? Existence and uniqueness is a function, real function. So we have for this x, this one is unique. For this value of x, the value g of x is unique. So this one is in g, this one is in g. By definition of a function. Okay, recall that or note that. Now we have x f of x is in G, and x g of x is also an element in G by definition of function, or exactly by the function, or exactly by the uniqueness condition. We must have f of x equal to g of x, and thus prove the first part, prove the first direction. F of x must be equal to g of x. Now let's prove the other one. Now suppose that for all x in A, f of x equal to g of x. We want to show this part. So suppose that we have for all x in A, f of x equal to g of x. We need to show that f and g are equal. Okay, so recall, if you remember, we need to show that f equal to g in terms of set. They are two sets. They are sets. So we will show that arbitrarily will always be, we show f is a subset of G and G is a subset of f. Okay, so let's show the first part. F is a subset of G. This part. How to do that? Let x comma f of x be an element of f. We need to show x comma f of x must be an element of G. Is that correct? This is that we need to show subset part. Okay, so now recall that we suppose for all x in A, f of x equal to g of x. So this is true just because f of x can be replaced by g of x g of x, and g of x is in G by just definition of function g, right? So x comma g of x is an element of G. Since f of x equals g of x, we have f of x is equal to x g of x, and therefore this is in G. So we have done the first part. F is a subset of G. Now we show the second part. G is subset of F. We do exactly the same thing. There are two sets, so let x g of x be an element of G. We need to show x g of x be an element of F. So now you know what to do, right? So we have x g of x equal to x f of x, just because they are equal by our hypothesis. We suppose this by our hypothesis. F of x equals g of x for all x in A. So f of x equals g of x for all x in A. So x g of x equal to x f of x, and x f of x is an element of F. And we're done. So exactly what we need to show. X g of x is in F. And this means G is a subset of F. So we did prove this part. F is the subset of G. G subset of F. Hence, F equal to G, which is the main part that we need to show. F is a subset of G, which is what we need to show. F equal to G. F and G are equal.